Okay, good day folks. Welcome to our course on geometric reasoning and the teaching and learning of geometry. This video set consists of 8 videos, possibly more, but so far 8 are planned, and I'm going to talk to you about why is geometry so difficult to teach to learners. Why do learners have a problem understanding and applying the theorems that they know? What is it about geometric reasoning that sets it apart from all other forms of reasoning? Okay, so let's start. I'm going to focus on the theoretical perspectives on teaching geometry. You can look at Jones's article online. It's freely available. Very informative article. As a geometry teacher, I suggest you read it additional to other materials that you've already read. Then we're also going to look at the Van Hille levels of geometric reasoning and the Van Hille phases of learning. We will also then visit, as a last focus, the notion of Mark Driscoll's geometric habits of mind. Fascinating work. Those two sections together gets me so excited about geometry, it's not even funny. And before we start, let's talk about a few things. And I will talk about it from my perspective as being a teacher of geometry. I've taught from public schools to private schools for 23 years of my life. And the last 13 years I've been at a tertiary institution, the University of the Witwatersrand, teaching prospective teachers how to teach geometric reasoning in schools. So the first focus on the screen is, what do you find challenging when teaching geometry? And my biggest challenge was teaching it to school kids. I would teach the theorem, I would make them learn the theorem, I would show them, listen to my language, I would show them the proof and make them learn that proof, and hopefully then hoping that something would stick there about how we did the proofs and how we learned the wording of those theorems. But sadly, every parents' evening the queue was almost out the door, with parents wanting to know, how come my child can do algebra but my child battled with geometry? What can you as a teacher do and suggest? You know what my answer was? Ma'am, your child could not prove the theorem on the paper. So the moment your child starts learning the proofs and learning the wording of that theorem, they will be able to do geometry. And you know, I believed that. For years, I believed that that is the way that geometry is learned. Until I studied further and I thought, sorry, very embarrassed, that is not the answer I should have given my parents. So it was always a problem. And it was always a challenge. My top kids would get 80, 82 for the geometry paper, and for the algebra they would almost get close to 100%. And I could never understand why. Brings me to the second point. Do you feel that your knowledge of geometry teaching is sufficient? Well, definitely in the days when I was in private schools and in public schools teaching it, definitely not. In hindsight now, I wished I learned the things that I learned as a tertiary educator. What I learned there, I wish I knew when I was in school. Okay, and that is the stuff that I'm going to be dealing with in this course. It's definitely not learning by rote that helps a child understand how to do and how to reason geometrically. Third focus. Where do we need help? Well, if I look back at my career, I would say I needed help to teach proof to the learners, number one, and to teach relational understanding in geometry, not instrumental understanding. Now we're talking about the work here of Richard Skemp. Okay, so that is what geometry is. It's a few relationships that are put in place, and based on those relationships, we make certain deductions. Okay, so the aim of this course will be to introduce some of the special features of geometry and its teaching and learning, particularly the work of the Van Hillers and that of Mark Driscoll. Those two together, combined in a geometry course, gives you a very, very good view on what geometric reasoning is all about and should be all about when we teach geometry to kids. Also, we will be examining the nature of geometry and how it can best be taught and learned at school level. We'll be doing that by looking at those two frameworks, the Van Hillers and the Habits of Mind by Mark Driscoll. Okay, so to work with school geometry in a way that supports the relational understanding of geometry. Some call it the conditional approach. So if these conditions are in place, these relationships are in place, you can then make a certain conclusion. But it's not about the picture, it's about the relationships in the picture. Okay, and then hopefully this course will strengthen your understanding of what it is and what it means to teach geometry effectively at a school level. Okay, so what is geometry? Let's try and answer that question from a historical perspective and also from our perspective as teachers of geometry. Well, geometry, first of all, is a visual thing. If you just think about the way you arrange your lounge, for instance, if you put a beautiful vase on a stand in a very center point of that lounge, it attracts the eye. But if you put it on the table, coffee table next to the couch, it might not serve the same purpose of being visually attractive. So all of that has to do with the geometry of the space that we have around us. Okay, geometry is also demanding to teach well. But to teach well, you need to know what research is saying about the teaching of geometry and how that teaching is different to what the teaching of algebra, statistics, are. How are those different? How's geometry teaching different to what we do when we teach algebra? Also, just to remind you, geometry is the oldest branch of mathematics. Examples include the Hindu Vedas, thought to have been composed 4,000 years before the Christian era. Now that is a long time. From 4000 BCE to 3100 BCE, folks, that is enormously big in terms of time. Those things existed then. Okay, so you can imagine if it started there, we are talking centuries and centuries. Communities, civilizations apart have had a chance to contribute to this whole geometric reasoning. Around 300 BCE, much of the accumulated knowledge of geometry was codified in a text that became known as Euclid's Elements. Now, folks, if you can get your hands on those elements, please try. They are freely available online. So just Google Euclid's Elements and just page through it and see the level of sophistication that was already needed then and how that has evolved over the years to become what we know as geometry today. Well, Euclid's Elements are 13 books that comprise the elements. They are formed on the basis of 10 axioms and postulates. Several hundred theorems were produced by the deductive logic that was introduced in these elements. So it makes for very good and interesting reading. There's an example of one of the pages in one of the volumes. The elements came to epitomize the axiomatic deductive method for many centuries. It is likely that no other works except the Christian Bible or the Muslim Quran have been more widely edited, used and studied and probably also no other work has exercised a greater influence on scientific thinking than Euclid's Elements. So it played a central role in shaping and informing, in developing and refining geometric ideas and geometric reasoning through the ages. So it's well worth a search, folks, if you can. Okay, so let's look at how geometry is defined. Now, if you Google this as well, you will find an endless amount of efforts and attempts to define geometry. I like this one by Sir Christopher Zeeman. He says, geometry comprises those branches of mathematics that exploit visual intuition. Again, the visual comes to the foreground. The most dominant of our senses is the visual sense. To remember theorems, to understand proof, to inspire conjecture, listen to the words, to perceive reality and give global insight. That is a very, very dynamic and beautiful definition by somebody of what geometry and geometric reasoning is to them. These skills are transferable and they are needed for but not taught by all the branches of mathematics. The skills you learn in geometry is not taught in algebra, is applied in algebra, yes, but not taught there. Okay, is applied in other fields, in science, in ICT, in design, in geography. All these skills that are taught in geometry are necessary for progression in those fields. So the aims of geometry, let's talk about that. It develops a spatial awareness, a geometrical intuition, and an ability to visualize. Now, folks, this ability is used by interior decorators. I've used the example of a vase. For instance, a vase or just a piece of art hung in a different place in a room has a different effect. Putting a chair next to a table with a lamp on it, all of that is the space around us and how we organize that space so that it's visually appealing. Is based on geometric fact. To provide a breadth of geometrical experience in both 2 and 3 dimensions. Okay, now this is huge. The move between 2D and 3D in geometry is big. A triangle on a plane which is 2D has different properties to a triangle on a sphere, to a triangle in hyperbolic space. Okay, so it provides, geometry provides the breadth of experiences for you to talk about this. What happens if I tessellate a 2D shape in 3D? What is a new shape formed? What happens there? Geometry also develops the knowledge and understanding of the ability to use geometric properties and theorems. It's not just learning them by rote. What does it mean if I can prove a theorem? Can I prove that theorem differently? Can I prove it without any input from the educator, from a child's perspective? Okay, and that's what geometry aims to do. It develops those skills that helps you do that independently. Then geometry also encourages the development of the use of conjecture, deductive reasoning, and proof. And again, that is applicable across various disciplines in life, in physical sciences, in geography, in architecture. The field is endless, folks. Latest scientific designs are based on geometry and the properties of geometry. Okay, so geometry also aims then to develop the skills of applying geometry through modeling and problem solving in real world contexts. Now we're going to look at a few of those as we progress through the course. It also develops useful ICT skills in specifically geometric contexts. Now, one of those just that comes to mind is the whole field of graph theory and matrix algebra. We are organizing numbers in a rectangular array. A rectangle is a geometric shape. How does that make it more easier to deal with algebraic properties? Okay, so those skills are all developed in the field of geometry to engender a positive attitude towards mathematics. In my years as a geometry teacher at school level, my children that understood the geometry I taught to them, it opened the world of mathematics for them. Often my best geometry or maths pupils will be art students. Okay, so you can see the connection. Okay, it's visual art, geometry. The level at which geometry starts is a visual level. Okay, so if a child does well in geometry, I've experienced over the years, everything else falls in place. Why? Because of the skill set they get through effective geometric teaching, dynamic teaching, relational teaching from the teacher. And then also geometry develops an awareness of the historical and cultural heritage of geometry in society, and then the contemporary applications of that geometries that was learned. You go into any mosque, you look at how beautiful the mosque has mosaic floors, mosaic walls in the Islamic world. It's beautiful in the ancient world. If we look at those are all geometric shapes that's been tessellated. It's found its genesis in the way geometry has organized the space in which it finds itself. Okay, so now we can ask the question, why include geometry in the school curriculum? And that is exactly why. The skill set that you gain from geometry and geometric reasoning is widely applicable across all subjects in maths. It develops the skill of visualization, of critical thinking, of intuitive perspective, problem solving, intuition, conjecturing, deductive reasoning, logical argument, proof. All of those are skills that are only developed by a professional teacher in the geometry class. And what this course will do is it will equip you with the tools to do just that. Geometric representations can be used to help students make sense of other areas of maths. If you just think about it, when you were in grade 4, maybe you can't remember this, but to make sense of fractions, we used the notion of a pizza. Pizza is round, cutting it up into equal parts. Now take that notion and disrupt it a bit and change it to a square and see if a child understands how the skills that was learned when geometry was used to explain fractions, do those skills transfer from a circle to a rectangle, for instance. There's a wide publication on that online called the Malati Materials, where they actually talk about these part-whole relationships, and that if we only stick to a little round figure to teach fractions with, it is so contextually bound that when we bring in a figure like a square or a rectangle to teach the same thing, it does not connect for learners. Okay, then also multiplication models. From arithmetic models to algebra models, we use an area model to teach children how to multiply two binomials together to form a quadratic trinomial. All of that is geometry, folks. The relationship between graphs and functions. If you think about it, transformations of functions is understood from a geometric perspective. What does it mean if I translate something 3 units up, 2 units left? Children can do that, but do they understand the geometry behind it? Often a child has asked me, "Sir, why if the change is in x and it says x minus 2, do we do the opposite on the Cartesian plane? Folks, the answer lies in geometry. Okay, so you will understand that even children that cannot interpret graphs look for the genesis of that, and it's in the reasoning, the visual reasoning that they've learned when they did geometry. Spatial reasoning is also important in other curriculum areas like maths, science, geography, art, design, and technology. You must be able to organize space, and that is geometry in action. So I hope that I've given you enough to think about what this course has the potential of doing for you. So please, folks, read wider. There's one reader that I'm highlighting here for you at the bottom, and that is the Batista work on spatial reasoning. If you have a chance, go and look for that article online. Just Google Batista spatial reasoning and read what this man says about spatial reasoning. You will see the connection to geometry is so strong. Okay, folks, I can't wait to start the course. So with that, my next video, I'm going to talk to you, let me see, I'll talk to you about the theories of learning for geometry and some of the big ideas that has been published about geometry and geometric reasoning. If you're watching this video on my YouTube channel, folks, and you learned something, please like and comment and subscribe to the channel so that you can get updates when I post something. Thanks for watching.